All right, so this next question that I want to go through is question number 9 from chapter number 17. And this question is really kind of a jargon or a terminology question more than anything else. And this question reads, let me pull it up so I can read the actual wording. The half equivalence point of a titration occurs halfway to the equivalence point. So an equivalence point is where you basically neutralize 100% of that acid with a base. So we're talking about this half equivalence point now, which is halfway to that equivalence point, where half of the analyte has reacted to form its conjugate, and the other half still remains reactive. Now, this question is a little bit tricky because what it throws at you is it says if 0.2 moles of a monoprotic acid with a Ka of 6.4 times 10 to the negative fifth. So we've got a monoprotic acid, we have this amount, is titrated with NaOH. What is the pH? Now, almost all this information is completely unnecessary. One thing that's worth noting, and a way that you can kind of tell that it's unnecessary, is that the question asks for the pH, but it doesn't tell you anything about the volume of the sodium hydroxide that's used. So this is more of a conceptual question than anything else. Now, the reason that this is, or the way that you can answer this question, or the way that you can think about this, is to think about what is the Henderson-Hasselbalch equation? pH equals pKa plus log of A minus over HA. Now, this is our half equivalence point. So essentially, if we have an acid, HA, and to that acid we add NaOH. Now, let's say that we have, 2 molecules of HA. Well, then, when we add 1 molecule of NaOH, we're going to react with one of them. And so what we're going to get then is A minus plus H2O, and, of course, the sodium as well. But here, what we're going to end up with is we're going to end up with a 1-to-1 ratio of HA to A. So we will have titrated half of that HA. Now, what that means is we're going to have log of 1 over 1. And that is the same as log of 1. And well, the log of 1 is equal to 0. So essentially what we're going to get is pH equals pKa. So the question is really, when you've titrated half of an acid with a base, what is the pH? Well, the pH is equal to the negative log of the Ka. So negative log of 6.4 times 10 to the negative fifth ends up being something like, this is my calculator a second ago. 6.4 fifth, log that, and we get approximately 4. Oopsies. Let's go back. We get 4.2. So our answer to this question is 4.2. All right, I hope that was helpful.